we take up a problem from three-dimensional geometry, and it is the second problem that we are considering now. This example has appeared in Joint Entrance Examination Main held on 20th July 2021 in the morning shift. The example is, let P be a plane passing through the points 3 points 1 0 1 1 minus 2 1 and 0 1 minus 2. Let a vector A is equal to alpha I plus beta j plus gamma k be such that A is parallel to the plane P and it is A is perpendicular to I plus 2j plus 3k and A dot product with the vector I plus j plus 2k is equal to 2, then alpha minus beta plus gamma whole square is equal to dash. It is a good question. The question asks you first you get the equation of the plane passing through 3 points and then test your knowledge about a vector parallel to a plane and a vector perpendicular to another vector and whether you can do the dot product of two vectors or not, and the resulting equations you have to solve. They are the non-homogeneous equations that you are going to get, and you have to solve them, get the answers of alpha, beta, gamma, and compute alpha minus beta plus gamma whole square is equal to so and so dash. We first find the equation of the plane P passing through these 3 points. Solution. We recall this result. The result is the plane through 3 given non-collinear points x1, y2, x1, y1, z1, x2, y2, z2. The third point is x3, y3, z3 is the determinant 3 by 3 determinant whose first row is x minus x1, y minus y1, z minus z1. Second row x2 minus x1, y2 minus y1, z2 minus z1. Third row x3 minus x1, y3 minus y1, z3 minus z1. And we have the three points 1 0 1 1 minus 2 1 0 1 minus 2. They are to be respectively taken as xi yi zi for I is equal to 1 2 3 respectively, and the equation of that such a plane is determinant of x y z x1 minus x1 minus 1 minus y1 0 minus z1 minus 1, and accordingly you fill up the determinant. Then this implies x minus 1 y minus 0, that is y only, z minus 1 0 minus 2 0 minus 1 1 minus 3. This is the equation. You expand this determinant by the second row. Expanding the above determinant by second row will get 0 here. It is the position is 2 2 position. 2 2 position means 2 plus 2 is 4. Therefore minus 2 into, there is no minus sign, minus 2 into the minor. The minor is x minus 1 into minus 3 into x minus 1, minus of minus 1 into z minus 1, that is plus 1 times z minus 1, and simplify, you will get the equation is 3x minus z is equal to 2. Thus the equation of the plane P is 3x minus z minus 2 is equal to 0. We continue the discussion in the next slide. That's your given problem. You have already calculated, you have already got the equation of the plane P, that is 3x minus z minus 2. So let us get into the problem. So what is given? So before going into that one, we recall these simple results which everybody may be knowing, but however we recall for some of the students. Let A is equal to A1I plus A2J plus A3K be a vector. B is a vector B1I plus B2J plus B3K. The dot product of A with B, A dot B is equal to A1B1 plus A2B2 plus A3B3. And the vector A is perpendicular to vector B if and only if A1B1 plus A2B2 plus A3B3 is equal to 0. These results are simple. Now, given A is equal to alpha I plus beta j plus gamma k, that is parallel to this plane P. The plane P equation is 3x minus z minus 2. Here you have to get the vector normal to P. The vector normal to P, that is n, is equal to, the vector n is equal to 3i minus k. So here 3x minus z, that is 3, 0 minus 1 are the corresponding direction ratios, and the normal vector to this plane will be n is equal to 3i minus k. So A is parallel to the plane, but this vector is normal to the plane. Therefore, this vector is perpendicular to this normal. And we know the condition of perpendicularity. So therefore, A dot n is equal to 0 because A and n are perpendicular. And use this condition, you will get 3 alpha minus gamma is equal to 0. The second one is given A is equal to alpha I plus beta j plus gamma k is perpendicular to this vector I plus 2j plus 3k. And you know the condition of the perpendicularity. This implies alpha times 1 alpha, beta times 2, 2 beta, gamma times 3, 3 gamma is equal to 0. That is the second equation. And you are further given the vector A is dot product with I plus j plus 2k is 2. So therefore you will get A is alpha I plus beta j plus gamma k, dot product with I plus j plus k. It will be alpha into 1, beta into 1 plus gamma into 2 is equal to 2. That is alpha plus beta plus 2 gamma is equal to 2. We got three equations in three unknowns, but these are non-homogeneous equations. So we have to solve to get the answers of alpha, beta and gamma. We have these three equations. Now to find the values of the alpha, you know how to get the three equations, three unknowns are there, how to get the values of alpha, beta, gamma. You do it whatever method you want, but I will show you a matrix method. So I will write the matrix of the non-homogeneous system. So it is a system of three non-homogeneous linear equations. Agreed. So we will write the 3 by 3 matrix. In the first row, I take alpha plus beta plus 2 gamma is equal to 2. That means the first row I will take it as 1, 1, 2 and 2. The second row I will take corresponding to this. The third row I will take corresponding to the first equation. So therefore this will be 1, 1, 2, 2 and 1, 2, 3, 0. 3, 0, minus 1, 0. So you got a screen here and it tells you that it is the system of three non-homogeneous linear equations. To solve this, we have to bring it to the echelon form. So to do that one, I'll make this position as 0 and this position is 0. And to make this position is 0, from R2 subtract R1, and to make this position is 0, from R3 subtract 3 times of R1. So R2 is equal to R2 minus R1, R3 is equal to R3 minus 3R1. If so, then this will be R2 minus R1 means 1 minus 1, 0, 2 minus 1, 1, 3 minus 2, 1, 0 minus 2 minus 2, and 3 minus 3, 0, 0 minus 3, minus 3, and minus 1, minus 6, minus 7, 0, minus 6, minus 6. So we got this. So this position I want to make it 0. Then to the third row, add 3 times of the second row. So R3 is equal to R3 plus 3R2. Thus we got this echelon form. This echelon form we got it. You need not make this as 1. And we will solve the answers for alpha, beta, gamma by the back substitution method. So this is your this by back substitution. First we take minus 4 gamma is equal to minus 12. That will imply gamma is equal to 3. We'll go backwards. That will be beta plus gamma is equal to minus 2. Gamma value we substitute and we get beta is equal to minus 5. And we'll go to the first equation. Alpha plus beta plus 2 gamma is equal to 2. And you know beta is minus 5, gamma is 3, you will get alpha is equal to 1. Thus, we got the answers of alpha is equal to 1, beta is equal to minus 5, gamma is equal to 3. Now, if we want alpha minus beta plus gamma, that will be equal to 1 plus 5 plus 3, that is equal to 9. And we want its square, that is 9 square, that is equal to 81. Therefore, our answer is alpha minus beta plus gamma whole square is equal to 81. So, this completes the discussion of the solution of this problem in three-dimensional geometry. I hope that you understood the solution of this problem, and you go home and go on working out some more problems in this direction. I wish you all the best. Thank you.